Sometimes you'll only be asked for a specific term of an expansion. So you shouldn't need to expand the whole thing if you remember the patterns. I'll show you how to think through one using the pattern, and then I'll show you a formula that you could choose to memorize. So let's look at exercise 4. Which of the following represents the third term when written in standard form of 3x plus 2y all to the sixth? Well, let's think about how this would start. This would start, we have an exponent of 6, so we need the sixth row of Pascal's triangle for coefficients, which is this row. So we want the third term, so the leading coefficient will be 15. 15 times our first term, 3x, and we're the third term in. So the first term in it would be to the sixth, then to the fifth. Now this would be to the fourth. And the next term, 2y, well, the exponents, remember, in the pattern we saw, always have to add up to the exponent on the problem, so that would be squared. So again, you don't need to expand the entire thing if you remember the patterns involved. So now you clean it up. 3 to the fourth is 81, x to the fourth, and this is times 15. 2 squared is 4, so times 4y squared. Well, we can eliminate choices that don't have x to the fourth and y squared, which would be choices 1 and 2. And then all you need to do is multiply your leading coefficients. But when you look at the choices, it has to be 4,860 when we multiply those big numbers. So the answer is choice 4. Let's do one more like that, and then I'll show you a formula that also works. For exercise 5, when written in standard form, which represents the middle term of the expansion, 2x minus 3 all to the 8th. Well, one of the other things you needed to notice is in an expansion like the last one on the previous video, when we were raised to the fourth, we get 1, 2, 3, 4, 5 terms. So if I have an expansion and it's raised to the 8th, that means I'm going to have 9 terms. Think about our sequences. If I have 9 things in a row, the 5th term is your middle term. So really we want the 5th term. Again, because the exponent is 8 on the expansion, my leading coefficient would come from the 8th row of Pascal's triangle, which means we need to do a little more work with Pascal. So we need 2 more rows in Pascal's triangle. So we'll keep adding previous terms to get the next terms. And here's our 8th row. So that middle term, the 5th row in, will have a leading coefficient of 70. The term will have a leading coefficient of 70. That'll be multiplied by the first term. Again, if I need the 5th term in, this will be raised to the 4th because it would have started at the 8, 7, 6, 5, 4. And then your last term, negative 3, will also be raised to the 4th because those exponents need to add up to 8, the exponent on the problem. To clean it up, 70 times 2 to the 4th is 16, x to the 4th. Negative 3 to the 4th is positive 81. So the first thing you can do is eliminate the 2 choices that are negative, and then go to your Inspire and figure out what the final cleaned up coefficient will be. You multiply 70 times 16 times 81, you get 90,720. It has to be choice 3. Now, as I said before, there is a formula you could choose to memorize that will also give you any term in an expansion. Here's what it is. NCr minus 1 times x to the n minus r plus 1 times y to the r minus 1. N is the exponent on the problem. R is the number of the term you're looking for. X is the first part of your expansion of your binomial. Y is the second part of your binomial. Let's practice this formula with exercise 6. Again, I rarely choose to use it. I choose to think about patterns, but for the formula people out there, You can use it. If you're not a formula person, you can try it using our pattern and see that you get the same thing. So here we go. N, the exponent on the problem is 6. C, r minus 1. Well, I'm looking for the last term. Again, what we talked about in the previous problem is that with an exponent of 6, that means there were 7 terms in the total expansion. So r is 7. So 7 minus 1 would be 6 times x, the first term in your expansion, 3x, times n minus r, 6 minus 7 plus 1, times the last term of your expansion, negative 2r, to the r minus 1. 7 minus 1 is 6. And then again, you would clean this up. Well, 6c6, anytime you have a number c itself, that's 1. 6 minus 7 is negative 1, plus 1 is 0. This is 3x raised to the 0, which is also 1. So all you need to really do is figure out what negative 2 to the 6th is. Well, negative 2 to the 6th is positive 64, and you have your y to the 6th. So the last term of that expansion is positive 64, y to the 6th. I'll leave number 7 for you to try on your own, and then check your answer against mine.